हेलो स्टूडेंट्स, हाउ आर यू? कैसे हैं सबके सब? बताइए। यस, हेलो स्टूडेंट्स, हाउ आर यू? जस्ट टेल मी, हाउ आर यू बेटा? फर्स्टली, हाउ मेनी ऑफ यू आर ऑनलाइन? जस्ट टेल मी, जस्ट टेल मी फास्टली. यस अनिल, वेरी गुड इवनिंग बेटा. कैसे हो? यस अनिल. व्हाट अबाउट द अदर्स? जस्ट टेल मी फास्टली. अच्छे हैं, ओके अनिल. कहाँ से हो अनिल आप? बताइए. यस. एंड व्हाट अबाउट द अदर्स? बाकी लोग कहाँ से हैं भैया? जरा फटाफट एक बार हेलो कर दें, सो दैट वी कैन मूव टू अवर लाइव डॉट सेशन. जल्दी से बताइए. यस अनिल, कहाँ से हो बेटा? फास्टली फास्टली. गुड इवनिंग हरीश. हाउ आर यू बेटा? कैसे हो हरीश? फास्टली. यस. गेट का फॉर्म भर दिया सबने? बताइए. सबने गेट का फॉर्म फिल कर दिया इस बार का? थोड़ा जल्दी बताएंगे. यस अनिल, हरीश, गेट का फॉर्म फिल हो गया बेटा? फास्टली. हो गया, ओके. यस राहुल, वेरी गुड बेटा. तुम में से पास आउट कितने हैं? पास आउट. ओके. हरीश, यू आर फ्रॉम तेलंगाना. ओके. ओके हरीश. हाउ मेनी ऑफ यू आर पास आउट स्टूडेंट्स? जस्ट टेल मी. कितने लोग पास आउट हैं? तो फिर आप लोग के लिए एक अपॉर्चुनिटी और बताता हूँ, बताइए. ओके, 2020 पास आउट फ्रॉम तेलंगाना. ओके अनिल. ओके हरीश, कंप्लीटेड. ओके. नाउ देयर इज वन मोर फॉर्म. ओके, जो अभी आया हुआ है, और वो है हमारा एसएससी जूनियर इंजीनियर का. यस राहुल, एसएससी जूनियर इंजीनियर का एक फॉर्म आया हुआ है हमारे पास, जो अभी 30 तक जिसकी डेट है. अगर आप चाहें तो उसे भी फिल कर सकते हैं. जूनियर इंजीनियर भी अच्छी खासी पोस्ट होती है, 50,000 प्लस सैलरी होती है, सेंट्रल गवर्नमेंट जॉब है, बाकी सब कुछ अच्छा होता है. अगर 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 बोलना नहीं चाहिए ऐसा, पर फिर भी अगर आप लोग उसमें सिलेक्ट हो जाते हैं, तो जितना मैंने आज तक अपने पर्सनल एक्सपीरियंस से देखा हुआ है, सैलरी को तो हाथ नहीं लगाना पड़ेगा आपको. ठीक है, इतना तो है. तो काफी अच्छा जॉब है. अगर आप उसके लिए भी फॉर्म भर देते हैं, ज्यादा महंगा फॉर्म नहीं आता, सिर्फ और सिर्फ 100 रुपीज का फॉर्म है आपके लिए. ठीक है, तो एसएससी जूनियर इंजीनियर का ही फॉर्म निकला हुआ है. यस. कितनों ने फिल कर दिया है? बहुत अच्छी बात है हरीश. अगर आपका डिप्लोमा बैकग्राउंड है तो आप तो बिल्कुल भर सकते हो. अगर आप फाइनल ईयर में हो तब भी आप भर सकते हो, क्योंकि अगर आपके पास डिप्लोमा की डिग्री भी है तो आप आराम से उस फॉर्म को फिल कर सकते हैं एसएससी का. उसकी मिनिमम रिक्वायरमेंट ही डिप्लोमा है, मिनिमम रिक्वायरमेंट. ओके हरीश. ओके अनिल, देन यू कैन आल्सो फिल दैट फॉर्म बिकॉज यू आल्सो हैड द डिप्लोमा कोर्स. ओके, आपने भी डिप्लोमा की डिग्री लेके रखी हुई है, तो आप भी उसको भर सकते हैं. अभी तक भरा था फॉर्म, या पता था कि फॉर्म आया है? ये बताओ मुझे. फॉर्म भरा था या अभी तक पता था कि फॉर्म आया है? बताओ, बताओ जल्दी से बताओ. यस. फास्टली. Harish, surveying incomplete means. Just tell me. हम लोग हर दिन बेटा एक एक सब्जेक्ट पढ़ते हैं। हम लोग ऐसा नहीं है कि डेली हम लोग एक ही सब्जेक्ट पढ़ रहे हैं। हमारा पूरा का पूरा टाइम टेबल सेट है, पूरे वीक का टाइम टेबल सेट रहता है हमारा, कि अगर हम लोग मिलते हैं कब, अपन बात करें कि वेडनेसडे को मिलते हैं, तो वेडनेसडे को हमारा चलता है क्या, आई थिंक दैट वेडनेसडे तो छुट्टी होती है, हाँ थर्सडे। यस हरीश, हम लोग हर दिन अलग अलग सब्जेक्ट लेते हैं। अगर थर्सडे की बात करें तो थर्सडे को हमारा चलता है ज्योमेट्रिक्स इंजीनियरिंग, जिसको हम लोग सर्वेइंग कहते हैं। ठीक है, आज जैसे फ्राइडे है हमारा, तो आज फ्राइडे के दिन हाइड्रोलिक्स चलेगा। ठीक, फिर फ्राइडे के बाद अगर सैटरडे की बात करें हम, तो सैटरडे को हमारा चलता है क्या, CMM, दैट इज कंस्ट्रक्शन मटेरियल एंड मैनेजमेंट। फिर संडे की बात करें तो चलता है हमारा एनवायरमेंटल इंजीनियरिंग। फिर मंडे की बात करें तो चलता है हमारा स्ट्रक्चरल एनालिसिस। और ट्यूसडे की बात करें तो हमारा चलता है क्या बेटा, ट्रांसपोर्टेशन इंजीनियरिंग। तो ये हमारा पूरा वीक का फॉर्मेट है। ठीक है, ये पूरा वीक का फॉर्मेट है। अगर आप चाहें तो आप इसको पूरा का पूरा नोट कर सकते हैं। ये हमारा पूरा वीक का फॉर्मेट होता है। क्लियर? फास्टली बताइए, इतना तक समझ में आया तो अपन आगे बढ़े फिर। ओके, नाउ आज का जो हमारा सब्जेक्ट है, जो आज हम लोग पढ़ने जा रहे हैं, वो हमारा है क्या, हाइड्रोलिक्स। और हाइड्रोलिक्स में हम लोग ऑलमोस्ट ऑलमोस्ट पिछली क्लासेस तक हमने पूरा पूरा रेले मेथड खत्म कर चुके हैं, बंकिंगम पाई मेथड खत्म कर चुके हैं। आज हम लोग जो स्टार्ट करने जा रहे हैं, यहाँ पे हम लोग सिमिलैरिटी पढ़ने जा रहे हैं। देखिए, कभी भी आपने सुना होगा कोई टरबाइन बनता है या कोई भी पर्टिकुलर एक अपन कुछ भी इक्विपमेंट बनाते हैं, कोई भी मशीनरी बनती है, तो उससे पहले उसका प्रोटोटाइप बनता है। बताओ, बनाते हैं क्या प्रोटोटाइप उसका? सबसे पहले अगर कोई भी हम लोग मॉडल बनाने जा रहे हैं, किसी भी चीज का मॉडल बनाने जा रहे हैं, तो उसका प्रोटोटाइप पहले बनाते हैं। बताइए, आप लोग भी अगर कोई घर वगैरह बनाते हैं तो उससे पहले उसका पूरा का पूरा एक 3D प्लान तैयार कर लेते हैं, जो कि कस्टमर को दिखाने के लिए रखते हैं। हाँ या ना? बताइए। यस, बोलो, बोलिए। सिमिलरली अगर हम लोग कोई भी आगे की तरफ अगर हम लोग अब जाएंगे, जब जैसे हाइड्रोलिक्स में बढ़ते हैं, तो कोई भी अगर मशीनरी बनानी है, कोई टरबाइन बनाना है, कुछ भी बनाना है, तो उसके लिए हम लोग क्या है, सबसे पहले प्रोटोटाइप बनाते हैं और सारी टेस्टिंग प्रोटोटाइप पे करते हैं। अगर प्रोटोटाइप हमारा सेफ हो गया, ठीक है, ओके अनिल, डेफिनेटली डेफिनेटली बेटा। नाउ अनिल, if we have to make any turbine or any type of machinery in the hydraulics, then first of all we have to prepare a prototype of that machinery, and we have to do all the testing on the prototype. If it will pass in all the testing over the prototype, then that shape or that figure is passed and we can make the model of that. Okay, but if the prototype fails during the testing time, then we have to change the prototype design, and we have to, yes, uh, suppose that uh, if this is a graphic tablet, suppose that this is a graphic tablet. Now if we want to make this graphic tablet, then first of all we have to make its prototype. What is the prototype? We have to make a smaller type of, just we can say that a smaller graphic tablet, and we have to do all the testing, whether it is fit for the writing purpose or not, whether it is compatible with all the windows or not, or whether it is compatible with the Mac or not. So if it will pass in all the testing, then we will take that design and we will just make the larger size of that, and the larger size of that prototype is known as the models. Is it clear to all of you? Just tell me. Yes, if we have to make a larger turbine, that is a model, and first of all we have to do the testing on the smaller turbine, that is known as prototype. Is it clear to you or not? Okay, yes Anil. Now first of all we have to see the geometrical similarity in between the prototype and the model. Now what is the geometric similarity? I had written here, for geometrical similarity to exist, the ratio of corresponding length dimension between the model and the prototype must be same. It means that the ratio of all the sides or the ratio of the dimension of model as well as prototype will be same for whole model as well as for whole prototype. So I had written here, that is the length of this dimension, that is length of AB, will the ratio of AB of the model to the ratio of AB of the prototype will be equal to the ratio of BC as well as the ratio of BC of the prototype. We are teaching only on the Zoom, beta. Anuj, we are currently teaching on Zoom also. Okay, that's why here it is written as Zoom here. Okay, now if we will take the ratio of the dimensions of the model and the prototype, then it must be equal. So if this will be equal, then it is known as the geometrical similarity. How many of you get the clear idea about the geometrical similarity? Just tell me. Yes, fastly. What do you mean by geometrical similarity? If the ratio of the sides of the model and the prototype are same, then it is known as the geometrical similarity between the prototype and the model. Just tell me fastly. Yes, Samyog. Very good evening, beta. Very good evening. Anil, Harish, is it clear to you, beta? Is it clear to you or not? Just tell me fastly. What do you mean by geometrical similarity? Fastly, fastly. Okay, Anil. Now we can just summarize the geometrical similarity. It is nothing but the ratio of the dimension of the model to the ratio of the dimension of the prototype. And if this ratio will be same for all the dimension, Harish, difference between model and prototype. Model is the actual, we can say that actual figure or the actual 3D object. Okay. And prototype is the smallest type of that figure or smallest type of that equipment over which the testing is done. Because if we are doing the testing on the larger type of equipment, then it will be costly. So we are just providing the same type of material over the prototype, and we are preparing the small type of machinery. Suppose that if we have to prepare a turbine, that is known as Francis turbine or any other turbine. Okay, Harish, I am giving you an example. I am giving you an example. If we have to make a Francis turbine, just listen to me. Okay, then the cost of making the Francis turbine is very high. The cost of making the Francis turbine is very high. Now, if we are preparing a large type of turbine and if we do the test on that turbine, and suppose that if that turbine will fail during that testing, then it will affect the economy of the project. Okay, it will affect the economy of the project. That's why we are not going to test the larger type of turbine. So we are preparing the smaller type of turbine, which is known as prototype, over which we are providing the same material, same testing condition, same loading, same water temperature. All the conditions are same as that of the larger type turbine, but we are testing smaller turbine. If it will fails, then we can change the prototype, and if the prototype will pass, then we will take that design and we will make the larger type of Francis turbine. Now it is clear to you, Harish? Just tell me. Now it is clear to you, beta? Fastly. Okay, Harish. Now, if we have to keep the geometrical similarity in between the prototype and the model, then the ratio of the dimension of model to the prototype will be constant. Here I had written here, that is the ratio of AB of the model to the AB of the prototype will be equals to BC upon BC, CD upon CD, DE upon DE. So if this condition holds, then it will be the case of geometrical similarity. Okay, done. Firstly, Is it clear to all of you or not? Yes, fastly. Harish, Anil, Samyog. Yes, fastly. Okay. Now, the geometrical parameters are what? It will be length, width, height, area, volume, diameter. So we can say that geometrical parameters are what? Geometrical parameters are length, width, height, area, volume, and the last one is diameter. Okay. Now, if we have to consider a geometrical parameter for the geometrical similarity, then we will take these parameters also, that is length, width, height, area, volume, and diameter, etc. Okay, clear? Now we can just say that length of model upon length of prototype will be equals to width of model upon width of prototype will be equals to height of model upon height of prototype, and we can just say that this ratio is known as LR, nothing but the LR, that is the ratio, nothing else. We can say that the ratio of length of model upon length of prototype equals to width of model upon width of prototype equals to height of model upon height of prototype will be equals to LR. It is nothing but a constant ratio. Is it or not? Just tell me. Yes, fastly. Yes, fastly. Okay. Now, if we have to compute the ratio of area of model upon area of prototype, then it will be equals to what? Length of model upon length of prototype, as well as width of model upon width of prototype. So we can say that this ratio is also known as LR, as well as this ratio is also known as LR. So it will be equals to LR square. That is the area of model upon area of prototype will be equals to LR square. Yes, Deepak, very good evening, beta. Very good evening, Deepak. Yes, very good evening, Deepak. So if we want to compute the value of volume of model upon volume of prototype, can anyone tell me what will be the value of volume of model upon volume of prototype? Just tell me. Yes, fastly. Harish, if we want to compute the value of area of model upon area of prototype, then area will be equals to what? Length into width. So for the model, we had multiplied here length into width of model. Similarly, length of prototype into width of prototype for the computation of area of prototype. Now, we know that the ratio of Lm upon Lp will be equals to Lr. Similarly, the ratio of Wm upon Wp is equals to Lr. So it will be equals to what? Lr square. Similarly, if you want to compute the volume, then it will be equals to what? Length of model into width of model into height of model upon length of prototype into width of prototype into height of prototype. So it will be equals to what? Lr into Lr into Lr. So it will be equals to Lr cube. Is it or not? Yes, just tell me, is it or not? Firstly, yes, 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 firstly. Is it clear to all of you or not? Just tell me. Okay, Anil. Now we can move towards the next type of similarity, that is known as kinematic similarity. Okay, we have to study two types of similarity, that is the geometric similarity as well as the kinematic similarity. Dynamic similarity will also be there, but the most important are kinematic similarity and the geometrical similarity. Now, for the kinematic similarity, the parameters are velocity, acceleration, as well as the discharge. Now, if we have to maintain the kinematic similarity in between the model and the prototype, then the ratio of the velocity of model to the velocity of prototype will be equal. Similarly, the ratio of acceleration of model upon acceleration of prototype will be same, as well as the ratio of discharge of model upon discharge of prototype will be same. So we can say that if we want to compute the value of velocity ratio, then it will be equals to what? It will be equals to VR, or it will be equals to what? It will be the ratio of velocity of model to the velocity of prototype. Okay. Now, just tell me what will be the value of velocity. Just tell me. If you want to compute the velocity, then it will be the ratio of length upon time. Is it or not? Is it or not? Fastly. If you want to compute the value of velocity, then it will be the ratio of length upon time. Is it or not? Fastly. Yes, fastly. Okay, Harish. What about the others? Velocity will be equal to length upon time. We had studied this concept from the basic of the mechanics as well as basic of the fluid mechanics. Okay, that is velocity will be equal to length upon time. Now, if this ratio will be equal to VR, so can we say that VR will be equal to LR upon TR? If this will be VR, so it will be equal to LR upon TR. Is it or not? Yes. Is it or not? Fastly. Yes, fastly. If this will be equals to VR, so we can say that VR will be equals to LR upon TR, because velocity will be equals to length upon time. Is it or not? Fastly. Now, LR is the ratio of length of model upon length of prototype. Similarly, TR is the ratio of time for model upon time of prototype. Okay, Anil. Okay, Anil. Now, if this will be equals, so we can compute the value of acceleration ratio also. So, acceleration ratio will be equals to what? Now, what is the value of acceleration ratio? It will be equals to AM upon AP, that is acceleration of model upon acceleration of prototype. So we can say that this ratio will be equals to AR. And we know that acceleration will be equals to what? It will be the change in velocity with respect to time. Now we know that velocity will be equals to what? It will be the length upon time. So it will be equals to LT square. Is it or not? Just tell me. Is it or not? That is the value of acceleration. Just tell me. Yes, firstly. Is it or not? Just tell me fastly. The value of acceleration. Okay, Anil. Okay, Harish. So we can say that it will be equals to LR upon TR square. Okay. So it will be equals to LR upon TR square. Yes, basic units, Harish. Basic units. The unit of acceleration is meter per second square. The unit of velocity is meter per second. And we have to compute the ratio of discharge also, so it will be equals to meter cube per second. Now we are going to compute the value of discharge ratio also. So discharge ratio will be equals to what? It will be the ratio of discharge of model upon discharge of prototype. So we can say that it will be equals to QR. So it will be equals to LR cube upon TR. Is it or not? Just tell me, is it or not? Yes, Anil, correct. Harish, we have to compute the discharge beta, and discharge will be equals to volume upon time. Okay, discharge will be equals to volume upon time, that is meter cube per second, Harish. So its value will be equals to LR cube upon TR. We can say that discharge will be equals to what? It will be the ratio of volume upon time. So it will be equals to LR cube upon TR. Okay, Harish, fastly. Is it correct, Harish? Just tell me. Okay, Harish. Now we are moving towards the next type of similarity, that is known as dynamic similarity. Now, for dynamic similarity to exist between model and prototype, identical type of forces, that is viscous force, pressure force, elastic, etc., must be parallel and must be at the same ratio at all the corresponding set of points. It means that we have to compare the value of force of model to the force of prototype, or the power of model to the power of prototype, because these are the dynamic parameters, and if these are the same or the ratio of these parameters are same, then we can say that there will be the dynamic similarity exist between model and the prototype if force ratio as well as the power ratio will be equal. Okay, so we are going to compute the value of force and power. Now force ratio will be equals to what? It will be equals to force of model, या force on model upon force on prototype. So we can say that this ratio will be equals to what? It will be equals to FR. Now what will be the value of force? Just tell me. What will be the value of force? It will be equals to mass into acceleration. Is it or not? Is it or not? That force will be equals to mass into acceleration. Firstly. So we know that density will be equals to mass upon volume. Now if we have to compute the mass, then it will be equals to density into volume. Is it or not? Is it or not? And if this will be mr, then it will be rho r and it will be vr. So we can write it here as mass will be equals to rho r into vr into ar. Now we know that vr will be equals to what? It will be equals to lr upon tr. We had already studied in the kinematic similarity. Similarly, the ar value will be equals to what? It will be equals to what? Just tell me, what will be the value of ar? Oh, just wait. Here VR is the volume, so it will be equals to LR cube, and acceleration will be equals to velocity with respect to time, so it will be equals to LR upon TR square. Now when you multiply this, then it will be equals to what? Rho LR to the power 4 upon TR square. That is the force ratio. Is it or not? Just tell me. Yes, correct, Anil. LR upon TR square will be the kinematic similarity of the acceleration. Kinematic similarity of the acceleration. Okay. Fastly. Okay. Now if we want to compute the power ratio, then it will be equals to what? Power on model upon power of prototype, and we know that power will be equals to what? It will be equals to force into what? Just tell me. Yes, fastly. Force into velocity. Is it or not? Force into velocity. Now we know that from the dynamic similarity that force ratio, that is Fr, will be equals to what? It will be equals to rho r into Lr to the power 4 upon Tr square, and we know that the value of Vr will be equals to what? It will be the ratio of Lr upon Tr. So if we solve this, then it will be equals to what? It will be equals to rho r into Lr to the power 5 upon Tr cube. Just tell me, how many of you get the idea about how can we find the kinematic similarity, dynamic similarity, and the geometrical similarity in between the model and the prototype? Just tell me. Yes, fastly. Fastly. Okay, Anil. Understood. What about the others? Okay, Shivam. Very good. Okay, Harish. Now can we move towards the next topic? Just tell me fastly. Can we move towards the next topic? Yes, fastly. Okay, Anil, Harish. Now we are moving towards our next topic, that is different types of forces acting on fluid mass. So we are writing here different types of forces acting on a fluid mass. Acting on a fluid mass. Now, what are the different types of forces that will be acting on the fluid mass? Just tell me. What are the different types of forces that will be acting on the fluid mass? Fastly. Yes, fastly. What are the different types of forces that will be acting on the fluid mass? Very good. Pressure, inertia, gravity. Anything else? Is there viscous force? Just tell me. Is viscous force is present in the fluid mass? Just tell me. Surface tension is there or not? Just tell me. Yes, Shivam. Firstly, yes, elastic force will be there. Yes. So these are the different types of forces which are acting on the fluid mass. We are going to find the values of all the types of forces one by one. Now, first we are taking the inertia force. Okay, the inertia force. Now, anyone is having any idea about what is inertia force or what will be the value of inertia force? Just tell me. Yes, it is a simple force. It is a simple force and its value will be equals to what? Just tell me. Its value will be equals to what? Yes, fastly. F will be equals to what? Yes, correct, Shivam Chauhan. It will be equals to mass into acceleration. Now we can say that mass is remaining as mass and we can just write it as acceleration will be equals to change in velocity with respect to time. Now we know that the value of mass will be equals to what? It will be equals to rho L cube. How this rho L cube will comes? Because it will be equals to density into volume and the dimension formula for volume is L cube. Similarly, we can write the value of velocity also. Now velocity will be equals to what? Just tell me. Velocity will be equals to what? Yes, fastly. Length upon time. Okay, correct. Length upon time. Okay. Now we will just keep one thing here as just wait for a few minutes. Okay. We are just converting in terms of our basic units. Okay. Now if we will write it as mass will be equals to what? Mass will be equals to density into volume. Okay. And volume will be remaining as v, and acceleration will be equals to what? Change in velocity with respect to time. Clear? Now suppose that if you want to compute the value of volume, so it will be equals to what? It will be equals to length into width into height. Is it or not? Yes, volume will be equals to length into width into height. Is it or not? Just tell me. That is the value of volume. Okay. Now, if all these parameters are same, then we can write it as rho into L cube, that is length ka cube. If all the parameters are same, so We will write it as mass will be equals to what? It will be equals to rho into L cube into V upon T. Clear? Now we will take 1L from this, so it will be equals to what? Rho L square, and we will just take 1L and divide it by T, and remaining velocity will be equals to V. Now L by T is what? It will be the change in length with respect to time, so it will be the velocity. So we can say that it will be equals to rho L square V square, that is the value of inertia force. Okay, we are just kept the all the parameters same, so it will be equals to rho L square V square. Firstly, okay, that is the inertia force. Now we had derived the inertia force. Now just tell me, what will be the value of viscous force? You all had studied the viscous force in the fluid mechanics. Now what is the value of viscous force? Just tell me. For acceleration we will get t square. Definitely not, beta. Acceleration will be equals to what? Acceleration will be equals to change in velocity with respect to time, beta. Change in velocity with respect to time. Now if we have to keep in terms of L, then it will be equals to what? L upon T square. Okay, that's why we are not going to keep this like, okay, we are just formulating the value of inertia force in terms of velocity. So we had taken this value of acceleration, that is change in velocity with respect to time. Okay, Anil, clear? We are going to derive the formula in terms of velocity, because we have to keep here velocity. Okay, very good, Anil. Now, what will be the value of viscous force? Just tell me, what will be the value of viscous force here? What will be the value of viscous force? Yes, it will be equals to what? Shear stress into area. Shear stress into area. That will be the viscous force. If we are multiplying the stress into area, then it will be force. And if we will multiply the shear stress into area, then it will be known as viscous force. Is it or not? Is it or not? Yes, firstly. Yes, Anil, Harish. Okay. Now, the value of viscous force, we all know that it will be equals to mu into V by L, mu into V by L, and area will be equals to what? If length and width are equal, then it will be equals to L square. So what will be the value of viscous force? This L cancel out. So it will be equals to mu into V into L. That is the value of viscous force. Okay. Now that will be the value of viscous force as per the definition. Clear? Yes, fastly. Okay, Anil. Now, if you want to compute the value of gravity force, if we are going to calculate the value of gravity force, then we all know that gravity force Fg will be equals to what? It will be equals to mass into acceleration due to gravity. Is it or not? Mass into acceleration due to gravity. Is it or not? Yes, that is Sehajpreet. Gravity force will be equals to mass into acceleration due to gravity. That is the very simple concept. Mass into acceleration due to gravity. Okay. Now we all know that mass will be equal to what? Density into volume. So we can write it as rho L cube, and the acceleration due to gravity will be written as g here. So it will be equals to what? Rho L cube into g. That is the value of gravity force. Okay. Similarly, we have to compute the value of pressure force. Now pressure force will be equals to what? Just tell me. Pressure force, it will be equals to pressure into area. That is the value of pressure force, because the unit of pressure is Newton per mm square, and if we will multiply it with the area, then this will comes out as Newton. So it will be the value of pressure force. Okay, now we know that area will be equals to what? It will be equals to L square. So the value of pressure force will be equals to PL square. Now just tell me, how many of you get the basic idea about the pressure force? Just tell me. Yes, fastly. Okay, Shivam. Okay. Yes, Anil. Now, if we have to compute the value of surface tension, that is our next force, that is surface tension. Okay. Now, surface tension will be equals to what? It will be equals to sigma, or we can say that F sigma, that is the surface tension. It is a force. So, if we will multiply the stress into length, then it will be the value of surface tension. So, the value of surface tension will be equals to what? It will be equals to sigma into L. Similarly, the value of elastic force. Elastic force will be equals to what? It will be equals to K into A, and it will be equals to KL square. That will be the value of elastic force. Now we had computed all the types of forces here. Now in our next class, we will see the various types of dimensionless number, that is Reynolds number, Froude's numbers, Euler's number, Weber number, Mash number, etc. Okay. So when we meet on our next class, that is on next Friday, we will see the various types of dimensionless numbers. Is it or not? Yes, just tell me fastly. Okay. So we had computed all the 6 types of forces, as well as we had completed the 3 types of similarity, that is geometric, kinematic and dynamic similarity. Yes, Savita, very good evening, beta. Yes, Harish, just ask me what doubt you will have. Just tell me what doubt, what type of doubt. Yes, Harish, firstly. Yes, Harish, firstly, beta. Definitely, definitely, Harish. Uh, if you want to see the basic formula of area, length, force, power, okay, I will definitely explain in our next lecture also on next Friday. But if you want to see right now, okay, right now, then you will see my first video of hydraulics, in which I had given you all the basic formulas, as well as we had find the dimensions of all that formulas. Okay, so if you want to see that, you have to visit our first video lecture of hydraulics. And if you want from my side, then I will just give you the formula of all these basic terms in our next lecture, that is on next Friday. Okay. Okay, Harish. Link, beta, it is available on our website or our channel, that is Ekeeda. Okay, you will just go and visit there. That video is available. Okay, Harish. Anil, here on YouTube, we are only just resolving the live doubt session. Okay, we are not covering the entire syllabus. We are just covering the important topics, as well as the doubts of all the students of Ekeeda. If you want the complete syllabus of GATE, then our package is available on our website, that is ekeeda.com. You will just go, the link is mentioned in the chat portion. Okay, you will just go and visit on our website. Our full package is available at a very reasonable cost. Okay, at a very reasonable cost. We are also providing the live doubt session just like this, as well as we are also providing the test series also. Okay, so if you want to get that access, just visit on our website. Okay, Anil. Till then, goodbye everyone. Bye bye. Shubhratri. Good night, everyone. Bye bye. Okay, Shivam. Bye everyone. Yes, Anil. Bye 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 beta. Bye.